we want to simplify this radical form. So this is cubic root, then inside we have square root. Cubic root, inside we have square root. So let's observe this. 5 radical 2 plus 7, 5 radical minus 7, conjugates, right? Difference of two squares. If we multiply these two, let's call this A, let's give them a name. Let's call this A, let's call this B, right? So what's A times B? A times B, so let's call this whole thing A, this whole thing A, this whole thing B. If we multiply those two all under cubic root, right, all under cubic root, then we get difference of two squares, which is the first one square. If we square this one, we get 50. We square this one, we get 49. 50 minus 49 is 1. Cubic root of 1 is 1. So that's the beauty of this question. So A times B equals 1. Now let's raise A by power 3. Let's raise B by power 3. Then the power cancels the index. So A raised by 3 minus B raised by 3. Right, would be this one plus 7 minus 5 radical 2 minus negative 7 becomes plus 7. These two cancelled, so we get 14. Okay, we get two beautiful values. So A times B equals 1, A cubed minus B cubed equals 14. Now let's expand this difference of two cubes. So that's A minus B times A squared plus AB plus B squared, right? And this one equals to 14. We know AB is just 1, right? But we want to form a perfect squares out of this. Let's see, so we have A minus B. We want to form inside here, we want to form A minus B squared. In that case, we need a negative 2AB. But we only have positive 1AB. So that means we have to add 3AB here. Then this equals to 14. So let's just multiply, distribute A minus B to both of this. We get A minus B cubed plus 3AB, or AB is just 1, so it's plus 3 times A minus B. Move 14 to this side, minus 14 equals to 0. Right? Now, how do we do this? Let's call this A minus B K. We want to treat A minus B as one thing, so K. So this is not easy to factor. This is a cube, this is a linear, this constant. So what do? Maybe we want to split negative 14 into negative A and negative 6. In that case, I can use difference of two cubes again, right? Because 8 is 2 cubed. So I'm gonna use K cubed minus 2 cubed, right? So this is K cubed minus 2 cubed. In that case, what do I get? So I'm gonna put this one together. I have a K cubed minus 2 cubed, right? I call this A minus BK. Then here I have 3K minus 6. Well, 3K minus 6, they share a common factor of 3. These are 2 cubes. So this again I can write as K minus 2, K squared plus 2K plus 2 squared, which is 4. Then this one, these two, I can factor out 3. I have K minus 2. Again, I have a common factor. So I have K minus 2. So K minus 2 times K squared plus 2K plus 4 plus 3, that becomes plus 7. Right? So what is my K? My K is A minus B. Now let's put back this. a minus b minus 2 times a minus b squared. I lost something, right? I lost here. Equals to 0. Equals to 0. Oh, right. Then plus. Well, I could solve for k first. Let's solve for k first, right? Before plugging. So by zero property, those two factors can be 0, so which means k minus 2 can be 0. Well, this one can be 0. Can this one ever be 0? K is a minus b, right? Well, let's see. So k squared plus 2k plus 1 will be perfect square, will be k plus 1 squared. So this can be written as k plus 1 squared plus 6. This will never be 0. So only possibility is k minus 2 is 0. That means k equals 2. Or k is a minus b. Right? That means a minus b equals to 0. Okay, we have come to this far. That means this is our a. What did I say? A minus b equals to 0. A minus b equals to 2. Because k minus 2 equals 0. And the k itself is a minus b. So a minus b equals to 2. So the answer for this in the end is 2. How beautiful is that?